Assalamu alaikum, dear students. How are you? The topic for our today's discussion is determination of national income equilibrium in three sector economy with induced taxes included. In our previous lecture, we have derived the national income equilibrium formula for three sector economy, and then we have calculated the multipliers for each consumption expenditure in the economy. We have derived the national income equilibrium formula with both income and expenditure method and the leakages and injection methods. Today again, by including the induced taxes in our national income, we will derive the national income formula with both income and expenditure method and leakages and injection method. First, we will derive the national income formula with uh, income and expenditure method, and then we will derive the national income formula with the leakages and injection method. Let's go to the slides now. The title of the slide is National Income Equilibrium with Induced Taxes and Extension. To calculate the national income level, we will use two methods, the income expenditure method and leakages and injection method. First, we will use the income and expenditure method. The national income equilibrium level through this method can be calculated by the formula that aggregate expenditure actual must be equal to aggregate expenditure planned. And as we know that the aggregate expenditure actual are equal to y, that is the aggregate supply, and the aggregate expenditure planned are equal to c plus I plus g, that is the demand of the economy, cumulative demand of the economy. So the national income formula is here, where the supply is equal to its demand, that y is equal to c plus I plus g, and we will derive now the national income formula by including the induced taxes with the following given information, that we have the consumption function, that is c is equal to c naught plus MPC/YD. Here MPC is the marginal propensity to consume and YD is the disposable income of the consumer, and YD is equal to Y minus T. The investment is autonomous. I is equal to I naught, and government expenditure are also G naught, while T is equal to T naught plus my, and the m is, sorry, ty, that is the t is the marginal propensity to tax with respect to national income. Now putting the values of these function into the our national income equilibrium equation, we put the value of c, the value of I and g, and the national income formula become y is equal to c naught plus mpcyd plus I naught plus g naught. In the next, we put the value of yd in the equation. The equation become y is equal to c naught plus mpc into y minus t plus I naught plus g naught. Now again we will put the value of t in the equation, where the value of t is t naught plus small ty mpty. Y is equal to c naught plus mpcy minus mpc into t naught plus mpty plus I naught plus g naught. Now we will multiply the mpc inside the equation, and we will obtain the equation y is equal to c naught plus mpcy minus mpc t naught minus mpc into mpty plus I naught plus g naught. Now what we will do now, as we have to calculate the national income y, we will take the all the variable which include y to the left side of the equation, and that will become y plus minus mpcy will become minus mpcy when we taken it to the left side of the equation, and the minus mpty will become plus mpty is equal to c naught I naught g naught minus mpc t naught. Now from the left hand side we can take a common, that is y, we take in common y, and the equation will become y into 1 minus mpc plus mpc into mt is equal to c naught I naught plus g naught minus mpc naught. And the national income equilibrium will become by dividing the right hand side by 1 minus mpc plus mpc into mt. The national income equilibrium will become ye is equal to c naught plus I naught plus g naught minus mpc t naught divided by 1 minus mpc plus mpc into mt. Here we used induced taxes, which state that taxes are positive function of the national income, and t is equal to function of the uh, y, positive function of the y, and it has two component. T has two component, mean that t is also autonomous, and it has some part that is induced, that is depends upon the national income. The autonomous taxes doesn't depend upon the level of national income, that's why it's called autonomous taxes, and while the induced taxes increases along with the increase in the national income. So we have portrayed the tax function on the graph, where we see that on horizontal axis there is the national income, and on vertical axis there are taxes, and the T naught is the autonomous taxes that remain fairly constant along with the increase in the national income, while TY we have seen here, that is the induced taxes, induced portion of the taxes, and these taxes increases along with the increase in the taxes. So taxes are the positive function of the national income. The slope of the tax function is shown by the marginal propensity to tax MPT, which state that what will be the impact of a unit increase in the income on the tax revenues. So MPT is equal to delta T upon delta Y, which shows that marginal changes in the taxes along with the increase in the national income. A low value of MPT means that a 1 unit increase in the income will bring a low increase in the tax revenue. A high value a high value of MPT mean that a 1 unit increase in the national income will bring a significant and high increase in the tax revenue. So we have studied yet now the derivation of the formula for national income with induced taxes, and uh, we have also studied in detail the formula for tax revenue and its graphical presentation. Now we will go ahead with the derivation of the multiplier when we included the induced taxes. We will derive all type of expenditure multiplier that include consumption expenditure multiplier, investment expenditure multiplier, government expenditure multiplier, and the tax multiplier, as we have calculated in the our previous lecture. So we will calculate these multiplier through income and expenditure approach for from national income equilibrium formula, and in the next step we will derive the national income equilibrium formula for leakages and injection method, and then we will calculate the multiplier with that formula as well. Going toward the slides, now we have calculated the formula of consumption invest now we have to calculate the formula for consumption, investment, and government expenditure and government tax multiplier from the NI equilibrium formula derived from national income and expenditure method. Number 1, autonomous consumption multiplier. As we previously stated, that income that increase the any type of planned expenditure So increase in any type of planned expenditure will increase the national income, but the increase in the national income will be much greater than the initial increase in the planned expenditure, and that effect is called the multiplier effect. And the multiplier for autonomous consumption can be derived by following formula: Kc naught is equal to delta y divided by delta C naught. So for calculating Kc naught, we will have to take the derivative of national income formula by the C, that is C naught. And as we have derived previously, the national income formula is now y is equal to C naught plus I naught plus G naught minus MPC T naught divided by 1 minus MPC plus MPC into MPT. Taken the derivative with respect to C naught, and we have seen here, so we have taken the derivative of the national income equilibrium and the multiplier for the consumption. So by taking the derivative of national income equilibrium, we have derived the consumption multiplier, and the consumption multiplier become curly y divided by curly C naught, that is equal to Kc naught, that is equal to 1 minus MPC 1 divided by 1 minus MPC plus MPC into MPT. Similarly, in the same fashion, we can calculate the multiplier for the investment and the government expenditure multiplier, and the multiplier will be the same because the denominator is the same, and in the numerator, if we take derivative, the derivative for all other variable will be equal to 0, and the derivative for the variable that we have taken will become 1. So the Kc naught will be equal to Ki naught, and that will be equal to Kg naught, and the formula for all of three will be equal to 1 divided by 1 minus MPC plus MPC into MPT. Uh, the only formula that will be different will be the formula of the tax multiplier, and the tax multiplier formula will be different in the fashion that a tax has an inverse impact on the national income, mean that whenever taxes increases, it will decrease the national income, and vice versa. So the formula for tax multiplier kt naught is equal to k curly y divided by curly t naught, that will be negative, that will be less than 0, because the impact of taxes on the national income will be a negative. As taxes increases, the national income will decrease. So we can calculate the tax multiplier formula by taking the partial derivative of the national income equilibrium formula by the taxes, and that curly y divided by curly t naught, that is equal to curly divided by curly t naught of the national income formula. The partial derivative of C naught, I naught, and G naught with respect to T naught will become 0, and the derivative of T naught with respect to T naught will become 1, and in the numerator there remain minus MPC, and divided by the formula of kt naught become minus MPC divided by 1 minus MPC plus MPC into MPT. So yet now what we have done, we have calculated the national income formula by using the aggregate expenditure and income method with induced taxes included in the model. We have derived the national income formula, and we have stated the national income formula y E is equal to C naught plus I naught plus G naught minus MPC T naught divided by 1 minus MPC plus MPC into MPT. This was the national income equilibrium formula. Then we have calculated the derivative of C naught, I naught, G naught, and T naught, and we have stated that we can calculate the multiplier for these variable through taking partial derivative with respect to these variable. And we have stated that the formula, the multiplier for C naught, I naught, and G naught are positive, while the multiplier for the T naught is negative. And now we take a numerical example for this whole practice, and we calculate first the national income equilibrium, and then we take an illustration of the multiplier effect through graphs. Now we take a numerical example, hypothetical, to calculate the equilibrium and all the multiplier. Let's suppose we have the following information. The information that C is equal to 40 plus 0.75y, S is equal to negative 40 plus 0.25y, I is equal to I naught, that is equal to 100, and G is equal to G naught, that is equal to 100, and T is equal to T naught plus ty, and t is equal to 30 plus 0.25y. The national income equilibrium formula we previously illustrated, putting the values in the national income equilibrium formula, and we have the national income that is equal to 544 billion rupees, right? So we have calculated the national income formula by putting these values in the national income formula. Now we illustrate the national income with the graph, and we seen here that on horizontal axis there is aggregate actual expenditure, and on vertical axis there are aggregate planned expenditure, while the curve that started from the origin is the aggregate actual expenditure curve, that is equal to y, that is the supply curve of the economy, while the curve that started through intercept is the aggregate planned expenditure curve. And we have stated that where the aggregate planned expenditure are equal to aggregate actual expenditure, there will be a national income equilibrium. It's mean that graphically we can state that where the aggregate planned expenditure curve intersect the aggregate actual expenditure curve, there will be an equilibrium of the economy, and there will be no deflationary and inflationary gap. And we have stated already that the national income in equilibrium will be 544 billion pkr at the point E. Now uh, we illustrate some multiplier effect on national equilibrium of change in any planned expenditure, numerically, as well as we will illustrate it graphically. Let's suppose that there is a change in the planned investment expenditure of rupees 50 billion. And here we say that through first we will calculate the multiplier, the value of the multiplier, and then we will calculate the impact of the change in the 50 billion through using the multiplier. So the multiplier formula for the investment is ki naught is equal to 1 divided by 1 minus mpc plus mpc into mpt. And we know that the value of MPC is 0.6 and the value of MPT is 0.2, taken in the above hypothetical economy example. And putting the values of these MPC and MPT, we have calculated the KI naught, that is 1.92. The multiplier, investment multiplier, is 1.92. It's mean that by change of $50 billion in investment, the national income will increase 50 into 1.92, and the total change in the national income by a change in the investment of rupees 50 billion dollar will be delta y is equal to ki naught into delta I naught, that is equal to ki naught 1.92 into delta I naught is 50. So the total change in the national income will be 96 billion rupees, which can be illustrated through this graph. Here we see that initial equilibrium was at E naught, where the national income was 544 billion, as we have calculated previously, and the change in the investment of rupees 50 billion dollar we have seen here shifted the planned expenditure curve upward, and the new equilibrium occur at E prime, where the national income has increased from 544 billion rupees to 640 billion rupees, and the net increase of 96 billion. This is termed as multiplier effect, where we have seen that an increase in the investment by 50 billion rupees has increased the national income by 96 billion rupees, and we have shown it by graph as well. Our next topic will be derivation of the national income equilibrium formula by using the leakages and injection method, and then by the inclusion of the induced taxes. Then we will, after derivation of the national income formula, we will derive the multiplier impact, and then we will take a hypothetical example. We will derive a hypothetical economy national income equilibrium through numerical formulas and graphical illustration, and then we will take the illustrate the multiplier effect through numerical and to the graph. So until the next lecture, Allah Hafiz.